Our next speaker now is Rajesh Kumar. Now, Rajesh is replacing Gavork Arakalian, the LA County entomologist. Gavork had another commitment this morning. So Mary Lou asked Rajesh to fill in for Gavork. And we're going to be hearing this morning about the insect fauna associated with the Muga-Ecosystem, with a special emphasis on Ambrosia beetles. And Rajesh has come to us from the Central Silk Board in India. Okay, thank you. Assam, India. Thank you, Rajesh.
Thank you. Good morning, everybody. My topic is insect fauna and associated with the Muga-Ecosystem in our silkworm ecosystem. So we have encountered so many pest predators and other insects, invasive insects, like from tea gardens to our ecosystem. So this is our area. We have to cover whole northeast, including Sikkim, this Arunachal Pradesh, and we are located here, this portion. So, and here in whole Upper Assam, we have all tea gardens, and in Lower Assam, we don't have so much tea gardens. Only in Upper Assam tea gardens, and in whole northeast, we have all 4 types of silks, and the temperature is 25 to 32 degrees centigrade in Assam region, and humidity it's 85 to 100%. And in the highest rainfall is recorded here in Meghalaya. It's 1200 centimeter here. And we have more insects here. See, India is homeland for all type of silkworms. This one is Muga silkworm. It's a primary host plant. This Som, Persea bombacina. These all host plants belong to Lauraceae family. And second, this is Litsia monopatella, Litsia salicifolia, and Litsia citrata. And this one, Samia ricini. We have 2 silkworm in our institute. This it's the host plants for this Samia ricina. It's a castor. Ricinus for primary host plant. Then tapioca and caseru, and this heteropanic fragrance, and the Evodia ferexifolia, and the Elianthus. And mulberry is all over India, and this the temperature is available in Manipur. So we are doing all silkworm here. So this is I will introduce this Muga. This is Anthracomansis. This is adult, and the eggs, and this field. We have to rear it outside, not in the room. So these are the color variations during larval stages: the first instar, second, third, fourth, and fifth instar. And rearing in the natural condition. While egg we have to release here in pouch, and automatically after hatching it will go to the tree, this first instar. But during first instar we have problem of ants. The 20 to 40% we are losing by red ants. And this third instar, these are crawling up and down here and feeding on the leaves. This plant is Persea bombacina. And this, while we are shifting this from, if one plant is over, then we have to shift it to another plants. Then is the collection of the silkworms. In the night we have to collect all the silkworms while it is matured, and we have to see, if we will see the mature silkworm, then we have to rub it, it will show the hollow sounds. Then it is matured. Then we have to release the silkworm to the same host plant sleeve, and it will spin the cocoon there. Then we have to collect the cocoons after 10 days. Then for next generation, we have to go for like that. This branch is of same plant, because it lays only on the Persea bombacina, same plant's stick. So we have to tie it, the female moths, and for 4 hours we have to go for this mating. Then we have to uncouple the moths. And this is the silk we obtained from these cocoons. This is the golden silk. It's a natural silk, and I brought it. It's here, the raw silk. And this is mulberry silk. This one is spun silk by waste cocoon, immersed cocoon, and this is from fresh cocoons, and this is from airy silkworm. And now I will show the insect This is Samir, it's another silk. And I conducted a survey in last year and got so many insect pests and predators. This is we surveyed this insect, parasite, predators, pollinators, insect pests, and this fungus, bacteria, the people who were doing in pathology section. And this Ambrosia beetle we collected from some plantation. See the damage here, and these are the holes available, and the galleries and eggs and its adults, and we completed the life cycle here. Then see here it is clear this damage. The branches are died here. Then this another symptom here. Then this. Then in tea gardens I surveyed, but I did not find any tea suitable borer in tea gardens. I surveyed around 20-40 tea gardens, and I collected twigs, dried twigs, these branches, but there is no infestation of that tea suitable borer. Then this in castor bean also I did not find. Then in Toklai, in World Tea Science Congress, I visited that when we installed. There also I contacted the scientist, but they told there is no infestation in tea garden. And it's another one, it's a major pest, it's a leaf galls, and so Persea bombacina, and it's a stem galls. It's unidentified, and I'm doing the rearing for this. And after life cycle, we will complete that. And this one, Poropsilla species, we got the new parasite, it is unidentified. And these are the galls. It's in the Lidsia monopatella, another host plant. And this is it's a new genus, and earlier it was reported from Japan, from monotypic genus, and the Japanese people told it's a new species under that genus. And these parasites also I recorded. And this is see the epidemic of this Agonocilus species. At one tree we found around 10,000, more than 10,000. And these are the predators. See, I saw in the field the beetle he collected, and I chased this dragonfly and taken the photograph. From that hole he collected and these are the predators available, and these are the pollinators and visiting insects. And this Lidsia salicifolia, these are the fruits. It's also the same host plant of Muga silcum in the wild condition. And the spider mites also, these are available in tea gardens, but now it is available in some plantation. We are getting problem by this tea garden, and we cannot use the insecticides because it's a highly sensitive silkworm. So we can go for only biological control or some other biopesticides or some other mechanical methods. See these scale insects, and these are the egg in the waxy pouch, and these are the nymphs. And this another one, bug sucking the shoots on the top on the both plants, and the fruit sucking. And this is spiraling whitefly. Also I recorded this first time from that region. This Allirodisca dispersus. And another one is, this one is Diluropora species. See, and there are some this parasite. It's feeding on the whitefly pupae and nymphs. And it's a life cycle I completed in the field and field condition, and we got some new this parasite, pupal parasite. It's all. These are another one. This Stephanist, there are some 5 species. It's a species complex. It's not typicus, but the people told that there are 5 species. We have to go for some molecular or something. And these are 3 species, Coxoidea. And these are the ants. See, the first instar to fourth instar, they are feeding on silkworm. Now we are losing around 40%. And this is another pest. It's a voracious feeder. But Thailand people, they are doing silk from this cocoon. And these are, we have to complete the life cycle for this, because these are defoliator in soil plantation. But always it is parasitized by Apentillus. I did not complete the life cycle for this pest. And this is another, it's a leaf miner. It's a major pest in both plantation. And sometimes it is full of leaf mines. So earlier it was recorded as Phytomyza by some people, but now I completed the life cycle and came to know that it belongs to the Gracilidae family. It's a moth miner. And these are the predators. For this also we are losing around 10%. Around 5, and this mantis religiosa, and this sinus bug, and this Eucanthicona, and this another one, and this Gylotropazidon we published from this ecosystem, and this we found some gynandromorph specimen silkworms. And this is another one, first time recorded from Meghalaya, and earlier they have recorded from this Andre Legalov from Yunnan, described a new species in 2005. And these are around 20 species are recorded, and predator and pest. See, it's feeding on whitefly, this one, and some predating on the larval stage is feeding on the aphids. And these are the collection. I preserved all the specimens, and this we have only the control. We have to go for pruning. After that, we will get the new leaves, final one. And thank you so much.
We have time for a couple of questions if anybody has some.
Rajesh, any sign of predators for the beetles or some sort of infection that you notice in the field?
No, there is no infection in the field notice. But I saw in some symptoms after seeing here in Huntington Garden, there are some symptoms are available in the field, in like nearby tea gardens, near to our plantations. But that time I did not know that these are the symptoms of this Ambrosia beetle group. But I think that will be definitely for these groups beetles. So sure, we will collect the specimen and we will see that.